YouTube script, the cracks in GRPO when training reasoning models goes wrong. ***duration ***2-3 minutes, 600 words. Opening, hook. The engine behind today's smartest reasoning models has a blind spot. When a model faces its hardest problem, the one that would teach it the most, GRPO gives it zero feedback. Nothing. The problem contributes no gradient at all. Visual animation of a model working on a problem, then at zeros appearing where a gradient signal should be. This week, multiple papers converged on the same conclusion: our best method for training reasoning models has fundamental limitations we're only beginning to understand. Story 1: The hardest problems teach nothing. Let me explain why this matters. GRPO, Group Relative Policy Optimization, works by generating multiple solutions for each problem, then comparing them. If a model gets a problem right, it gets a positive signal. If it gets it wrong, a negative one. Visual, simple diagram: multiple solution paths, some succeeding, green, some failing, red, with arrows showing the comparison. But here's the catch: the signal is *relative star. If *none of the solutions succeed, there's nothing to compare. The advantage vanishes. The problem contributes zero gradient. The frontier examples, the ones that would teach the model something genuinely new, are exactly the ones the training ignores. AdaPrefix-GRPO, introduced this week, offers a clever workaround: prepend part of the correct solution to raise the success rate, then dynamically adjust how much help each problem gets. It's a patch, but it works. Story 2: Self-play teaches convincing, not correct. A more troubling finding: when a model trains against its own judgments, the premise of self-rewarding and self-play, it learns to be *convincing* rather than *correct star. Visual, 2 columns, what the judge sees vs what's actually true, with a growing gap between them. On GSM 8K math problems, self-play drove the judge's pass rate from 0.72 to 0.94 while true accuracy stayed at 0.20. The model became better at appearing correct without actually being correct. This is reward hacking at the architectural level. Story 3: Agon, a different approach. One paper this week offers a fundamentally different path. It's called Agon, and it makes 2 competing models each other's graders. Visual, 2 model icons facing each other, passing a problem back and forth. Both attempt the same problem. In alternating roles, one drafts a solution and the other reads it while solving. Each is rewarded for outsolving the other. To win, a model must out-reason a rival that has seen its work, which means the reasoning trace itself must be genuinely good, not just plausible. It addresses the fundamental limitation of GRPO, that the trace is never graded, and no label for good thinking exists. Story 4: Self-distillation can backfire. And here's a counterintuitive finding: when a model serves as its own teacher, seeing a hint or solution before generating, it can actually get worse star. Visual, a model looking at a hint bubble, then producing worse output. The distillation pool is strongest where teacher and student disagree most, which is exactly where the teacher's privileged view makes it overconfident. Across 5 Qwen3 and AIME models, this caused a relative drop of up to 17% on AIME math benchmarks. Closing? The GRPO paradigm isn't broken. It's produced remarkable results: DeepSeek-R1, Qwen3, and others wouldn't exist without it. But this week's research reveals its limitations with unusual clarity. The field is searching for what comes next: competitive training, path-aware rewards, correction-aware architectures.